my name's Allison Gray. I'm an assistant professor at the University of Washington. I am going to spend the next 15 minutes or so talking to everyone about a bit about data access, about how to begin to discover, obtain, and examine GO-BGC data, or BGC Argo in general data. This whole effort really, this data access tutorial was a very, it was a great group of people who put a lot of effort into this. And so I wanted to acknowledge members of the organizing committee, especially Andrea, Rue, Steve, and Yui, as well as all the people who really are working hard to put on this language-specific tutorials that we're going to break out into in about 15 minutes. Okay, and then especially thanks to the OCB, US CLIVAR for sponsoring the workshop, and then of course all the funding agencies for sponsoring this program. Okay, so the format, which I think maybe Andrea covered a little bit, but we're gonna, I'm just gonna talk briefly about language agnostic parts about getting started with float data. And then we'll break out into these hands-on tutorial sessions in breakout rooms and really give you a chance to practice selecting data, finding data, downloading it, and starting to look at some of the float data. Of course, in 60 minutes, we're only going to be able to kind of scratch the surface of what you can do, but hopefully this will be a good learning experience and you can get started. Okay, so please ask questions via Slack or the chat. And we also have help desk channels where you can get help either now or sort of later on too. We'll can continue the discussion after the workshop. I also want to kind of, before I say anything about data access or working with the data, I really want to encourage you to, if you haven't already, watch the pre-recorded talks from Tanya Maurer on data management, as well as Yui Takashida about data, about the sensors themselves, but also particularly for today's topic about how the different adjustments are made. Because we're going to be working with the adjusted data. So if you want to know what that means for each sensor, I really encourage you to look at Yui's talk and all the references that he's provided as part of that. Okay, so there's really, I'm going to say just 3 steps maybe to identify or to using GO-BGC data and to getting started. So the first step is discovery. So which floats do you want? What data do you want? What's out there? Maybe you already know, maybe you deployed some floats and you know exactly which floats you want to look at, but maybe you don't know. Maybe you just have an idea of a question and you want to see what's available. So the first thing we're going to talk about is sort of how do you find what floats you want? And then the next thing, once you do that, is to retrieve the data. And this is, there are several different ways to do this, and a little bit depends on kind of what format you want your files in and what other sort of questions and other particulars of your research topic. And I'll talk a bit about those and what, where to go for different types of files. And then last, you're going to open your files and start to analyze your data. And that's the part we'll cover kind of more specifically in the breakout rooms, because it kind of depends a little bit on your language, programming language. And then lastly, the fourth step is, of course, while we're all here, is to do science with the data. So we're not going to talk about that, but what we're going to do is just give you, talk about the first 3 steps to kind of get you started and get you set up and ready to do some science with this data. Okay, so there are multiple different access points, which is great because there's lots of options for discovering and retrieving float data. And it could be maybe, if you're just getting started and you don't know what any of these are, it could be a little bit confusing about what these different options are and why you would want to use some versus others. And so I'll just spend a few minutes talking about that. So this These different panels all came from our GO-BGC website. And if you go there, gobgc.org, and you go to data access and visualization, you'll see these different things, which all have links, and you can learn a lot more information. So the first thing I want to point out, though, is the first sort of one of these float data access points that we're going to spend more time delving into with the hands-on part of the tutorials. Is this the GDAC. Actually, let me switch. Before I get into the specifics, what I wanted to say was about sort of, I mentioned this before, what file format do you want? So there's several different types of file formats, and many of these access points let you access the multiple types of files, but some of them are specific to some types of files. So what do I mean by these types of files? Like the main two classes, and I totally stole this slide from Tanya's talk, and so thank you, Tanya. And but this is sort of my slightly adaptation of Tanya's much more thorough and much more informative description of these different types of files. But essentially, there are sort of two main types of files that you could get the data in. You could get the data from the GDACs, and that's the Argo Global Data Assembly Centers. And these are all in netcdf file format. And they use the Argo convention for the QC flags. And there's multiple types of files. So you can have a sprof, which is our synthetic profile. This is particular to the BGC Argo files, but it's essentially the profiles that you want to use. There's also the trajectory information that's in a separate netcdf file called the trash files. There's a metadata file associated with each float, as well as some technical data. So there's a lot of information on the GDAC. There are no, however, derived variables. So this is sort of for the GO-BGC and BGC Argo community. This is one of the main sort of differences between these types of files, is that the Argo files have no derived parameters of any sort. And so if you want to use the derived carbon parameters that the GO-BGC and SOCOM program have computed, then you won't find those in these files. Otherwise, if you are familiar with netcdf, or you're learning netcdf, and this is really kind of for research purposes, I would say the netcdf files on the GDAC is the sort of go-to source, and in particular the sprof. I want to make sure that those are the most easily usable profile files for the BGC Argo data. And then these are also archived monthly with a DOI, and the real-time data is available within 24 hours, and the DOI happens monthly, like I said. Okay, and then the other sort of type of file are the files that are produced by Embari and Scripps. And these kind of have two flavors, like the kind that you get from FloatViz, which Todd nicely showed. These are ASCII files, and they're compatible with ODV. So if you use ODV, then this is a great resource. They, as Todd showed, and I'm not going to really talk about ODV, I think, anymore, but this is also a really easy to use web interface, FloatViz, and it does contain the files that you can access here, which are text files, do contain the derived carbon parameters. So this would be DIC, PCO2, alkalinity, and so if you're interested in those, then this is kind of one of these, either FloatViz or the archived snapshots is the place to go. And there's both a high resolution and a low resolution format available, and that depends on the vertical sampling. And so many of the BGC variables are only sampled at a lower vertical resolution. And so that we have a file format where we take out the TNS data that aren't co-sampled with the BGC variables, so that you only have the places where you have BGC measurements, versus the high res has all the data. And these ASCII file form, the data that's in the ASCII files are also archived in these snapshots. These snapshots are nice because you have both an ASCII version, but you also have netcdf. And so if you're interested in using the derived parameters, they're in these netcdf, and you want to use netcdf, then this would be the place to go. So this is currently done through sort of associated with SOCOM, but will be all the MBARI float data are being archived through these snapshots. Okay, so once you know which kind of file you're really going for, then you can kind of start to decide how you want to access the data. And like I said, the GDAC is really the place to go for direct data access. And it includes all BGC Argo data, not just GO-BGC data. There's a lot of information that you can get by clicking on these links about how the data is formatted from the Argo data management team, as well as the BGC data management team. And this is what the index of the Coriolis GDAC looks like. So you have these profile index files that we'll talk about later in the hands-on tutorial. But so I think the hands-on tutorials in the different breakout rooms are going to be really focused on interfacing and accessing data through the GDAC via these profile index files. So I won't say anything more about that here. So I'll just say a little bit more about maybe some of these other ways to find and access data. So if you go to our website and the data access and visualization, if you go here to data access and visualization, you will find all of these links. So this is a really great starting point. As I mentioned, we're going to dive into the GDACs in just a moment, but there's also links here to an ERDAP server through the NOAA Polar Watch ERDAP server. So this is a really powerful way to access GO-BGC and SOCOM float data. It also has a lot of great visualization capability. So I'm not going to really say much about it here, but especially if you already use ERDAP servers, this would be a really handy resource. But if you want to find GO-BGC data specifically, another way, like I mentioned, was the float viz, which is linked here. And then we also supply our own map, our own interactive map, which you can find here if you go to array status, float locations, and data. And you can find this interactive float map, and you see our initial floats that have been deployed in the North Atlantic. So if I hopefully zoom in, you can hover over any one of these floats, and you'll find the WMO ID. So this is like the primary identification of the floats. You'll find also the last latitude, longitude, and date of the last profile. And then you'll find links, several links. You can go right here to the sprof file at the GDAC. You can also click on this link. So float status from the Euro Argo. Maybe if I do that, there we go. Okay, so if I click on that float status from the Euro Argo, fleet monitoring, this is a really handy website, and it's one of several that kind of lets you easily view Argo data. This is not just for BGC Argo, but it's for any Argo files. But you can see here a lot of information about this float. You can see what kind of sensors were on the float. You can see what transmission system. You can see the information about when it was deployed 2 months ago, if it's active, how old it is, all sorts of different things. You can also look at the data plotted in a variety of different ways. So this is a really handy website to go to, and you can, it's also linked on that main data access and visualization page, but this is the main page for the fleet monitoring from Euro-Argo, and you can, you know, select data, select floats from all sorts of different parameters, and you can go down here to BGC, get only active BGC floats, and you click on any one of these. There you can see they're all listed by the WMO. One of these, for example. Okay. Another way to interact with the GO-BGC data is through this float table, and this is a really powerful resource too. If you know, for the GO-BGC floats themselves, you can click on this table and you can sort it by different ways, and all of these links give you access to files from the Argo GDAC, or again the Imbari ASCII ODV file. It's a text file. There's lots of information about each float. Okay, so that's kind of these main 4 float data access points. And then also wanted to point out these data visualization pages. This is the one that we were just looking at with the Euro-Argo fleet monitoring, but we also have linked here to ArgoViz, which is a really great resource for looking at not just BGC Argo data, but also all Argo data. And encourage you to kind of play around with this website and see the different capabilities and functionalities. There's an API that you can use to interface with all the Argo data from the GDAC. And then here you see the BGC profiles are actually shown in green. And this is just a different way to visualize the data, and is a really nice resource. And there's also beginning to pull in various different gridded products, and a lot of different cool applications are being integrated into the ArgoViz platform. And then OceanOps is another platform that lets you, or sort of website that lets you plot data from the whole Argo fleet, as well as other observational networks. Next, we're going to break out into the different rooms for MATLAB, Python, and R. But if there are any questions before we do that.
There's a chat that says NetCDF files only contain one profile. There are NetCDF files that only contain one profile, but the sprof files have everything.
Yeah.
Just wanted to clarify.
Yeah, thanks, Ken. That's correct. As is the case for the TNS profiles, there are you can from in the GDAC there, for each float has its own folder, and within that folder you can access individual profile NetCDF files, but then there is a file that contains all of the profiles, and that's usually, I would say, what researchers would interact with is either the sprof or the there's it's just called prof.nc for the TNS files.